Today, I'm going to be speaking about accelerating the adoption of AI at your company and how Cast, we help do that. What does that even mean? I think no one knows, right? But it's provocative. But in general, who is Cast AI? Cast AI, we are a Kubernetes automation platform specifically focused on helping you run your Kubernetes environments cost effectively and also helping boost performance and how we do that. Some of our customers, right? Some of these logos you might notice, some you might not, which is a unique thing in Kubernetes, right? Is that we've had some customers that come to us really small in size, head count wise, but extremely large in compute size, right? And some of those types of customers are here. This is among 200, 250 of our total customers that we have. And what we're helping them focus on is exactly what we're going to be talking about today. I think everybody here is very familiar with how AI has taken storm, right? I think it was last year, and the graph shows that adoption of actual AI, machine learning, all these buzzwords have been around for some time. But McKinsey, this is McKinsey's source, it's showing that has increased significantly over the last 2 years, right? And also the use of generative AI, right? So there's AI adoption, and the use of generative AI at companies has extremely blown up, right? Skyrocketed. And with that, costs have gone right next to that, right? So it's almost a one-to-one correlation. The more you use AI, the more your cloud bill is, right? And that's what Cast is helping companies focus on, that problem, solving that problem. And this is a quote from a recent article in a partnership that Cast has made with Hugging Face. I don't know if is everybody familiar with Hugging Face and what they do? Got a good laugh here, right? So this is the CTO, right? Just really focusing on how Cast is enabling them, right? So Hugging Face has a free tier that they offer to developers, and we're helping make that free tier more cost effective for them, and also making the cost of using their platform better for you, right? And developers. And this is a real world example of a cluster that Cast AI is helping manage, right? And you could see that this is a cluster that's running an ML job training. And this is a typical type of cluster where your cluster is now having this huge surge of demand, right? It's requesting a ton of compute. And typical native autoscalers, whether it's AWS, Azure, or Google, they just aren't built to manage the upscale very well. But more importantly, as you see, is the downscaling events they're horrendous at managing the downscaling of resources. And if you go even further left, the developers, hope I don't offend anyone, are really bad at how much resources they even need to request to run those jobs, right? And so this is what Cast, number one, gives visibility into. How much are your resources even requesting? How much are they using? And then how much are they over provisioning? So there's 3 layers to that cake. And the first piece, I think it was the CNCF published a report last year that said that 13% of compute is actually used. I don't know, if I did only 13% of my job, I probably wouldn't have one, right? But this is a unique space that we live in, is that only 13% of compute is being used at the resource level, right? And so this is specifically what Cast AI is helping drive change in customer environments. And how Cast is doing that is in a number of different ways. I was almost speaking to this. I got a little ahead of myself. But the over provisioning, right? This is what the cloud is spinning up, right? You say, hey, I need 10 cores to run my app. It spins up 3 or 4 nodes, or maybe just 1 node, and that's over provisioned because now you're running a 16 core box to run this 10 CPU job. And then it's only using one CPU, 2 CPUs, right? And this is one of the huge culprits of the waste in these types of applications, the unwarranted headroom, right? Both on CPU and on memory. Memory is a little bit different, right? But memory is also 10 times cheaper than CPU. right? And there can be a lot more overhead. And you want to make sure that there's overhead in the memory so you're not getting any performance issues. And then low spot usage. Anyone using Spot today? Good. Awesome. One of the big knee-jerk reactions of Spot is, oh, I'm going to have interruptions. I'm going to have interruptions because the cloud, they could just decide, hey, thanks for using Spot. Somebody actually wants to pay for that. We're going to take it back from you. You have 2 minutes to get your machines off of that, or you're going to experience downtime. But that is the blessing of what Mike was talking about, what Kubernetes is, right? It's supposed to be highly dynamic. It's supposed to give you this opportunity of always being and having uptime. But Spot specifically, the way that Cast is able to manage it is really unique, right? We have an opportunity because we have so many customers and so many different clouds. We're having an opportunity to look at where are customers experiencing Spot droughts, right? What AZs they're experiencing those. And so we're applying machine learning to that specifically to analyze, okay, hey, so we're seeing these resources being requested back from US East 1. They're seeing a spot drought. We can then automatically start spinning up what we call fallback on-demand nodes that are able to move your workloads from Spot to these on-demand nodes to make sure that there's no interruptions, right? No downtime, no issues with those workloads. Is there a solution? Of course, right? That's what we're here for. Again, this is just demonstrating a typical cluster, right? You see the uptick in the actual cores. This is a decent size cluster, around 2,000 CPUs on what it's requesting versus what the cloud is provisioning. So it starts way up here. It gets a little bit better in provisioning here on the upscale, but then it just continues up and keeps going up and up. And then when this cluster is done using those resources, they're still up and running, right? And this is a problem that is very difficult to solve manually. Almost would say somewhat impossible, right? And this is what Cast AI is helping their customers specifically do, both for AI workloads, but also any other type of workload that you're running in your Kubernetes clusters. And then you see what it looks like when Cast is now becoming the autoscaler, right? It's a lot more fine-tuned across your workload. It's understanding how much you're requesting, and it's provisioning a lot closer to the requested state. And again, we should have a third piece down here. I'll get to a little bit later. We call it the workload optimization, right? And so it's doing on-the-fly workload requests regardless of what your developers are saying, right? And that becomes the getting your usage as high as possible. This is a specific customer environment from Akamai. You're seeing this super highly dynamic cluster, how they, throughout the entire day, right? This is 9, 11, 1. So this is a continuous day where they're seeing this huge spike up and down trend. Typically, you just see this cluster that just stays, I'm requesting this amount, right? The cloud is just going to have a flat line across the top just because we say that's what we need, but not with Cast, right? We're managing up, we're managing down, we're scaling up and down with the cluster to make sure that you're getting the most out of what you're paying for so that customers can continue to invest those resources in other places, such as training workloads, such as hiring a new team member, right? When I speak to customers, we always ask them, hey, we're going to save you X amount of dollars. What does that do for you? How does that help you? Where can you then invest those resources? People are like, oh, I have this developer tool that I want to buy, right, for my team, or I actually want to hire 2 more people. I spoke to a customer the other day. They're like, oh, yeah, we want to spin up more availability zones. Cast is helping them do that by making sure that they're getting the most bang for their buck. Another specific customer environment here, but I want to get to the workload, right? This is, again, out of the box. Cast AI is giving you visibility into all of your clusters, regardless of cloud, right? EKS, GKE, AKS, it's all the same to us. But you're also getting fine-tuned, like down to the workload, down to the namespace level of understanding how much these workloads are requesting, right? And you can see here that this specific resource is saying, I need 0.3 CPUs to run correctly. How did we get to that point? Who knows? A developer made it up. They just said, this is how much I need. Don't ask me any questions. Ship it. Whether you're using Argo or whatever else you're using for GitOps, That's what we want. That's what we need. But then you put a microscope on it, and now you're able to monitor these things and seeing what is actually being used, what's actually being requested, and it's a lot less, right? The max usage, 0.2. So you're over provisioning there, P75. And this is where we start to get really interesting with developer sandboxes, right? Or non-prod environments, is that you can typically endure a little bit of a more aggressive fine-tuning on the workloads themselves in a non-prod environment, right? But this is the type of visibility that we're granting to customers that are using us. And the way that we do this is a mutated webhook, right? So we're doing it on the fly. I think it's Kubernetes. They keep moving it out, right? Kubernetes 1.31 or 1.3. They've kicked it down, the can down the road, but doing it in real time without having the pod having to restart, right? I think they've said that it was going to be available for the last 2 versions, but now they just keep kicking it out. But once that happens, this is going to be super effective. We have kind of 2 ways that we can do this. There's one where we could do a hard reset of the actual pod itself. Some people are okay with that. Some people are not, right? If it's a Java workload, probably don't want to have that hard reset because it's going to have to now start over and have that huge spike of utilization in the very beginning. Or we could do apply those recommendations on the next natural restart, right? And so this is how customers are getting the utilization out of the actual workload optimization. And this right here, interesting colors, right? But ultimately, what you really want to pay attention to is we have the light blue, which is what they're actually requesting in on-demand, but the dark blue is spot utilization. And so this customer is using a ton of spot in their cluster, and it's almost entirely spot, right? We have some customers that are running 100% spot in production with Cast, and it's just the reason that how we do that is, like I mentioned earlier, we're constantly looking at the market. We're a little bit faster in spinning up nodes in real time that the native autoscalers are as well, and just migrating those pods over if needed, right? But sometimes people pigeonhole themselves into only using one type of spot instance. We have an ability to help you, what we just call spot diversity, which is enabling us to spread out the types of workloads on different types of spot machines so that you're not, AWS is reclaiming all spot VMs of the R family or the M family. But because of Cast, we're putting some on the M6s, we're putting some on the R5s, C6s, things like that. That is a huge advantage for folks who want to run on spot. And the reason why customers are doing that is because spot is significantly cheaper than an on-demand resource. Sometimes 90% cheaper, right? I call it the sales rack of the cloud. And this is a huge incentive. Number one, for all non-prod environments, we're pretty opinionated, that you should be using spot as much as you can in non-prod, right? Because why not? And hopefully your devs aren't holding a gun to your head and say, no, we need on demand. It's rather, no, we need to save costs and make sure that you're getting the same type of performance, right? A quick story on spot is that Cast, we're looking at the entire node families of every cloud every 15 minutes. And we're analyzing it. We're saying, can we move workloads to a more cost-effective node? Yes or no? Every 15 minutes. Customer A saved $250,000 with Cast in a 2-month period because we found a specific spot sale that AWS is running, and we just started moving the workloads to these spot workloads over and over. It was actually a GPU machine. It was a GPU machine that was on sale, significantly cheaper than any on-demand node, and we started rotating those into their cluster. And they raised their hand one day. They're like, hey, why are we using GPU machines? We're not actually using the GPUs. It's just no one's using these machines in AWS, and AWS is giving away for free almost. So we started using those. Great performance, no downtime, right? Nobody's using them, right? So there was no interruptions, right? And it saved them a huge amount of money. They're getting great performance. And this is what Cast is really great at. This is automation, right? No one wants to sit there, I forget who it was. No one wants to sit there and just monitor the cloud marketplace and say, oh, man, this machine's on sale. I can use it finally. And it takes time to spin those resources up and then spin them off when they're no longer usable. This right here is a free resource. If you go to our website, we call it this specifically is the GPU machine like map. So it shows the availability zones and where those GPUs are being used. And it gives you the hot spots of how much is being used in US West 2 or US East 1. Same thing at spot interruption rate, spot pricing market. It gives you an entire breakdown of the spot market and GPU market now. And this is completely free. It's at cast.ai, spot availability map. I think if you just Google spot availability map, it should be the first thing that pops up. And this is really interesting because you can start to strategize, where do I want to look for GPU machines that are spot and which AZs they're most affordable, but also have the least amount of interruptions, right? The next thing, so when you sign up with Cast, it gives you what we call a savings report. It reads what your cluster is doing. It's reading all the families that you're using, all the different types of machines. If I'm being completely honest, it's never this diverse when somebody plugs in their cluster. It's using all M6A 2XLs. Why? Who knows? Somebody decided it 2 years ago, and that's what they kept running, right? And then we're going to give a recommendation on if you were to bin pack your workloads better, it's typically a ton of overhead and nodes specifically, we can take you from around $4,000 a month to $1,400 a month by one, mixing in different types of machines, more diversity of like spot or on demand, but also getting the workloads into a tighter amount of nodes possible. It's just like playing like, number one, I'm a sales guy, right? So easy thing of how I picture it is just playing Tetris with your workloads, getting as many of the workloads on one node as possible. And that's what Cast gives you out of the box as a recommendation engine. And when it comes to applying the automation piece of what Cast does, that is ultimately what we charge for. We give cost monitoring for your clusters for free, right? That's something that we believe should be free. There's other tools that charge for that, but we give it out of the box for free, right? And what Cast is as a whole platform, if anybody's going to KubeCon, there's a bunch of announcements that are coming out about the platform. We're doing things around database. We're doing things around storage. We are a Kubernetes security product out of the box as well. So there's a bunch of things that we're doing just beyond the auto scaling and resource management. But we're focused on trying to be a true platform for all developer and infrastructure teams that are using Kubernetes. And we have a nice little calculator now on the website. You can go in and punch in, hey, here's my monthly cost of Kubernetes. Here's how many managed CPUs that I'm running. And it'll give you a rough breakdown of ROI based on our customer average. So our customer average is right around 60% of cost savings from everything that we talked about: workload optimization, spot diversity, bin packing, right? You start to put these things together and they become a force multiplier with one another. I wanted to just show a quick demo of the platform as well. I think I might have just clicked out of it. Let me see here. This is a demo. My demo. There we go. So when you sign up for Cast, you come here and it gives you this availability page, what I just showed, right? It's breaking down the exact machine types that you're using, and it's going to start showing you, hey, you're running 100 different instances at 1,300 total CPUs, but we can say, hey, we could get you down to 24 different types of instances at 600 CPUs. Huge amount of cost savings, right? And then also start trickling in some of the actual spot family, right? Give you a dashboard of here's what your cluster looks like. Here's how much you're provisioned. Here's how much you're requesting. And you can see here on this demo, it's actually utilizing a ton of the resources that it's requesting, right? This is out of the box. This is what you're getting for free using Cast. On top of, you can break down the node list, see how much, like what is the node efficiency, right? You can see here, typically when we talk to customers for the first time, nodes are pretty similar to this 40, 50, 60. Sometimes when we get up to the 70 percentile, we're like, wow, okay, you're doing a pretty good job. You must be, if you're using Amazon, you must be using one of the free open source tools that they, have to help do this exact problem. Bless you. And then the security piece, it comes out of the box. It's giving you a breakdown of potential attack paths, CIS benchmarking, vulnerability, and all of these things is what you're going to do, or what you're going to get when you go to console.cast.ai and you sign up. But outside of that, I think I breezed through that pretty quickly. I'm done. Does anybody have any questions? We have one question in the back.
I'll give you a two first. That's two questions.
Okay.
One person, two questions. So one question is for workloads. Let's say like we know general rule of thumb, databases don't really ever want to run them over 80% utilization.
Mm-hmm.
Doesn't matter. I could try to get close to 100% utilization, but I'm going to have a really bad day as a result.
Mm-hmm.
So what do you do in those kinds of situations where the headroom is intentional? It's not, oh, we don't know how to optimize our thing. It's, yeah, we've tried to optimize it more than that, and it turned out really bad.
On the resource level or on the node level? So on the specific workload?
You just keep it super simple and say 80% CPU utilization.
Yeah, if you're getting 80% CPU utilization, that's, I would say, best of class, right? When it comes to what we feel bin packing, right? If you're running it on your database on Kubernetes, you can do a much better job of getting more workloads on the nodes themselves. But I have my engineer here. I saw him creeping up that he wants to. This is George, by the way.
Hi, I do technical things. But to really answer your question, what we're giving SREs is tools to define things that drive values. So in your database case, we give the ability to say this, I want 20% overhead in terms of memory, 20% overhead in terms of CPU. Let us tell you how much you're using day to day. And that's what's really going to give you value. Because what we've seen is that a lot of people just aren't sure what those values are. And so we give you the visibility into those values and then say, how much overhead do you want to define? What is it reasonable to have in terms of 80% CPU availability or 100% CPU availability? And so you control how much overhead you want. We just tell you how much you're using, and then we can put you on more cost-effective instance types to help you save as much money as possible. So that's the answer.
Cool, thanks. And then the second is a little bit of a follow-up to that is like, I have some workload that I've deployed. Let's say I did it a year ago and we put it out on CPU optimized nodes because because our capacity planning. But 4 months ago, one of my developers shipped something and it turns out that I'd be much better off on a memory optimized node now. I didn't go back to do the capacity planning because that's life. Things get shipped. We don't know. We don't analyze every single thing that gets shipped. Is there something inside the platform that would say, hey, CPU utilization, we've got you exactly what you wanted, but it turns out that's not where your problem is. You should really be thinking about switching over to a different optimization strategy.
Yeah, so what we've seen across about like 1,000 to 2,000 clusters is that a lot of people think that specific classes between, let's say, R5, R6, R7 will really help them increase efficiency. From a cost perspective, it actually is a little bit of a wash. Like maybe you'll increase throughput on an R7 by, this is just arbitrary, but let's say you got 20 or 40 more requests per second per CPU per node. But from a cost perspective, it might cost you 3 to 4 times as much. What we do is we have, instead of you defining what instance types you're using, we pull from the availability of every single possible instance type you could use, and then put your workloads on that. So actually for us, what you'd be defining is, I don't want to use maybe bare metal instances. Maybe I have incompatibility with them, or I don't want to use ARM instances. And then we would just choose from the availability pool of everything else, and then substitute those in as you have more unscheduled pods come in. And so I guess we abstract that problem away because we're not really worried about the individual instance types that you're using unless you have a core requirement on them. Like you could tell us like, hey, only pick the R family. And then we'll just substitute in the things that make the most sense for the workloads that are coming in. I guess the answer should be, you don't worry about that anymore. And the reason for that is we don't think it's always meaningful work, but as SREs, you want control. We give you the control, but we pick from everything and then you shorten that down to what matters to you. I know you.
Sorry, one sec for the recording. So how can the user specify the policies that they want? For example, I want 20% over provisioning and so on. Is that like a laundry list of those rules, or do you help with setting up those rules? That's question number one. Once the rules are set up, do you use a lot of statistical analysis to suggest the optimizations, or where do you use LLMs?
Yeah, that's a fun one. So I'm going to answer the second question first, and then I'm going to go back to the first. So where do we use LLMs? He covered it a little bit, but in that spot availability map, we have an LLM on the back end that takes in all of the data from across the spot market, AWS, GCP, AKS. We'll look at interruptions that are happening across the entirety of our fleet and say this is the percentage that it could happen. And then when we look at your instance types and you're using Spot, we say there's a 13% chance this could be interrupted. We're going to spin up a new node that is a different instance type of what it is you're using and then migrate that over. So when we say make it easy to use AI, we're actually almost just abstracting that out so that you don't have to worry about that in terms of what Spot instances we're choosing, because we're just choosing from the availability of every Spot instance you could, and then we're seeing which ones are more sensitive. So that's how that gets baked in. And it's actually just like a one-click button in the UI. It's very like demure. It's just, and now you have all of this processing power in the back end. In terms of your first question, it's the way Cast works is you define a policy of what it is you want your workloads to look like. And then you could use labels or annotations or what have you, whatever's easier, to say, I want all of XYZ workloads to be under this policy. And then you can group the definitions of, I want 10% for this, 20% for this. But we don't go so far as to make that recommendation for you. We can give you defaults and we give you all of the information you need to make that recommendation yourself, but we don't replace SREs. Y'all know your applications the best. We're going to respect whatever it is you tell us from an overhead perspective, but we can tell you over the last 7-day period or 1-day period, that look back period is kind of configurable. We use a heuristic to say this is the amount of CPU you've used 70% of the time, 50% of the time, 80% of the time, or 100% of the time. And then you can peg us to that number. So that's how you would pick that number in terms of overhead or amount of CPU percentage.
Thank you.
If you want to answer.
Yes, a little more question about the LLMs that you guys use. So one of the questions is why LLM, right? So far I've been hearing maybe algorithm would be able to handle a lot of those things, especially since when you enter the LLM territory, you get things like hallucinations. All of a sudden it's going to tell you need 20 CPUs to host your tic-tac-toe or something like that. So I guess it's like a two-parter. How do you guys manage, if you guys are leveraging LLMs, the hallucinations to ensure that it's outputting correct information, the correct results, and especially since it's horrible at math. And the algorithm, why not to go with a more traditional algorithm, or maybe it's a mixture you guys have, or I don't know. This makes sense?
For our bin packing algorithm, we're not using an LM. We're just using a standard kind of ML. Here's all the ML model where here's all the data, get an output, drive that back out. Where we did decide to use an LLM was the spot market because it felt more dynamic and we were actually less risk adverse. Sorry, we wanted to be more risk adverse in the spot market. And let me give you an example, right? If I messed up and didn't migrate workloads from the spot market over to a new instance type that wouldn't be interrupted, then you could very potentially experience an interrupt in terms of availability because that spot instance is going down. So we actually index towards being more risk adverse and just creating that instance anyways and migrating you over, even if this specific instance type has a percentage chance of being interrupted. because that's going to cause less interruption, although it's going to cause a little bit more creation of nodes. So in this case, we use an AI model. It's more dynamic. And yes, there are hallucinations sometimes, and that's preferable to having an interrupt event that could affect your production processes. In other places where we're just doing straight math, we'll use an ML model with algorithms, they'll compete, and then we say, this is the algorithm that won. Just apply that to your cluster in terms of how we're bin packing things. But the answer to your question is we use it sparingly in very specific places where we're a little bit more risk adverse. And we think that's the right model because of the kind of risk profile that your production clusters might have.
Okay, makes sense. Thank you.
I think that's it. And we're a little bit over time. We are set up here in the back. So during a break, if you have more questions or want a demo, please come back. We're more than just a SOC company, right? We are a Kubernetes automation company, but we have plenty of SOCs. We'll love everybody to take one home because I really don't want to go back to FedEx and ship the box back. But thank you for the time.